right, so I'm going to start the webinar right now.
Perfect. And so we are live streaming on YouTube.
All right, so welcome everyone to the Northeast Student Data Core Data Science Career Panel Series. We're so excited that you all could join in for this month's career panel, and you'll be hearing from 4 amazing panelists on their data science journeys within their own respective careers and beyond, as well as receiving their advice and insights regarding how you can leverage data science in your own journeys. So sit tight, we'll be starting promptly at 3 p.m. Eastern. All right, for those who are just filing in and joining the webinar, welcome. If you came to hear 4 data science panelists discuss data science and career development with me and co-moderator Scott Blender, you came to the right place. So we'll be starting the event shortly. So just sit tight and we'll begin at 3 p.m. Eastern. All right, it is now the top of the hour, so we will officially be starting the event now. Welcome again, everyone, to the Northeastern Data Core Data Science Career Panel. I'm Haley, an undergrad at Columbia University and project coordinator of the NSDC, and my co-moderator today is Scott Blender, an undergrad from Temple University and the president of the Northeastern Data Core Philadelphia chapter, which he'll be speaking more about later on in the program. So Scott and I have a lot in store for you all today, as you'll be hearing from our four panelists, Benjamin Harvey, Juan Lavista Ferres, Kuldip Singh Atwal, and Marie desJardins. We also have our four great panel facilitators. Some will be helping run this event from backstage virtually, and others will help later on in the program. So let's just start off with today's agenda. Lauren, next slide, please. Great. So first, I'm going to give a brief overview of the Northeastern Data Core, who we are and what we're about. Then some important announcements regarding NSDC resources that you can access via our website. Next, we will be at the meat of the event, which you all came here for, the panel discussion led by Scott. And then following that discussion, Scott and I will speak more on the NSDC chapters, an initiative that Scott actually pioneered and that will lead into a discussion regarding volunteering opportunities with the NSDC. And then finally, for our last 30 minutes of the event, we will have an open Q&A discussion where you'll be able to pose any questions you have for the panelists and our great facilitators and student assistants. Benji and Juan will announce them live to the panelists for them to answer. So let's get into the thick of it. Lauren, next slide, please. Awesome. So the Northeast Student Data Core is brought to you all by the Northeast Big Data Innovation Hub. So the Northeast Big Data Innovation Hub is a community convener and collaboration hub. We create and enable a network designed to fuel data science innovation through diverse and inclusive community partnerships with academia, higher ed, K through 12, STEM programs, industry, nonprofit, really anyone who wants to be a part of a network of people in data science. And these partnerships allow us to connect with students, communities, and institutions across the United States and around the world. A really essential part of this mission of the Northeast Big Data Innovation Hub is to increase and expand data science capacity and talent across different areas of focus. So as you can see, we have four main focus areas. The first is education and data literacy. And under this focus area, the Northeast Student Data Core is our premier program and the one you'll be learning about more today. Under health, we have the COVID Information Commons, which provides a portal to 1,000 NSF-funded COVID research grants and a community of collaboration and support. In fact, the NIH is joining this community as well. And then there's the urban to rural communities where we have our working group. And finally, there's a responsible data science, which includes security, privacy, and ethics. And one of our cool programs under this area is the Connected Healthcare Cybersecurity Workshop Series. So you can access more information on each of these focus areas and their corresponding activities on our website at nebigdatahub.org/about. Next slide, please, Lauren. Great. So on the next slide, we want to talk to you more about the Northeast Student Data Core. The NSDC was created as a community developed initiative, and we wanted to really foster a diverse data science community that started with the students and educators of data science. And so last year we did a call for participation and had over 20 people interested in creating the foundation of the NSDC, including researchers, professors, folks from industry, nonprofits, undergrads, grad students. And they happen to make up the founding committee, all the faces you see on the screen, the people who really helped build this program from the ground up. And we organize the work done through the NSDC through three different teams. So the first is content and pedagogy. That helps to build a curriculum leveraging academia and industry generated resources and materials to teach data science fundamentals. From their great work, we now have Learner Central and Educator Central that I'll discuss more in the next slide. And for another team we have is Peer Instructors team, which consists of graduate, undergraduate, and postdoc students, as well as professors who mentor and enable data science learning remotely for students who don't have access to these kinds of programs. They play a significant role in shaping the students' experiences, and this team started their work through the Slack channel that we've launched. So you can actually access the Slack channel to connect with others, request mentoring if you want, and we'll be continuing to evolve that program as the Slack channel grows. And this team is also broadening through our volunteering program and volunteering opportunities. Last but not least, there's the outreach team who identifies and enables collaborators interested in engaging the NSDC to increase data science education and knowledge. This includes higher ed institutions, students interested in engaging with the NSDC, and government institutions that employ data science, providing real world examples to teach practical translational skills. So the outreach team is also responsible for the data science career panel series. So overall, the NSCC is really the breath of our community. So we'd like to really thank each team for their leadership and great work. And you can find more information on NSDC at anybigdata.hub.org/NSDC. Lauren, next slide, please. Okay, so there are a couple of ways you can use the NSDC. First, we have Learner Central, where you can find resources that cover data science fundamentals for students of all ages. This content is organized by difficulty level, so you can start with basics or jump into ethics and practical applications. We have supervised machine learning, as well as R and Python. We're also looking for new content to add to the Learner Central portal, and we plan to grow this section of the NSDC in the near future. Similarly, we have a portal called Educator Central, where teachers at all levels can find a range of valuable materials to develop or extend a data science program. We've included videos, presentations, lecture notes, and code examples from places like IBM, UC Berkeley, MIT, Columbia, Queensborough Community College, and other organizations to really help teachers build a comprehensive data science curriculum for students. Finally, I'll mention our Career Central feature. So for students interested in data science, but kind of unsure what steps they can take to advance their career, we provide Career Central. Here we point students to job search websites specifically for data science. We also provide guidance on how to prepare for interviews, polish your resume, or even practice technical and behavioral interview skills. So like the previous ones that I've showed you, all these resources can be found at anybigdatahub.org/NSDC. Next slide, please. Okay, so for today, we are delighted to have our 4 panelists here join us. We have Benjamin Harvey, Director of Data Science at Maxar and Senior Faculty Researcher at Johns Hopkins University. Next, we have Juan Lavista Ferres, Chief Scientist and Lab Director of the Microsoft AI for Good Research Lab. And then we have Kuldip Singh Atwal, postdoctoral researcher at the University of Central Florida. Last but not least, we have Marie desJardins, Dean of the College of Organizational, Computational, and Information Sciences at Simmons University. So now I'd like to pass the virtual mic off to Scott Blender, our moderator for this panel discussion. Lauren, please feel free to stop sharing your screen now as we transition into this discussion with the panelists. And Scott, feel free to take it away.
Thank you so much, and hello everyone. Thank you so much, Kelly, for their great introduction and for introducing all of our panelists today. For our first question for today's panel, we really want to get into it and ask each of our panelists to tell us a bit more about what they do currently and their own personal journey in data science. We'll start with Benjamin and then transition to Juan, Kuldip, and finally Marie. So without further ado, Benjamin, would you mind sharing with us what you do presently and your own personal journey in data science?
All right, excellent. So first off, it's a pleasure to be with everyone today, and I'll jump right into it. So currently I am the Director of Data Science at a space infrastructure company called Maxar Technologies. I have a PhD in computer science. A little bit about my dissertation work. I did a genetics and genomics analysis on large-scale cancer data. So as you guys can see, there's a diverse background that I have across space technology as well as genetics and genomics. My postgraduate work was at MIT and Harvard, where I did a set of analyses, continuing that research on large-scale cancer genomics. And then, believe it or not, to kind of further diversify some of the background that I have, I ended up working at the National Security Agency. So at the NSA, I had a plethora of positions, my last 2 positions, and one of them is going to be really interesting for the group. But I was the lead data scientist for the Edward Snowden leaks. So I know a lot of the individuals in the audience will will be familiar with who Edward Snowden is. And a lot of that information is top secret, so I can't tell you that. But I will tell you that we were responsible for analyzing and applying machine learning algorithms to better understand the data that was taken out of the building. Before I left NSA, my last position there was the chief data scientist of the operations directorate. So in that particular position, I was responsible for a cadre of about 40 senior data scientists, and they traveled across the organization answering some of the most challenging problems throughout the operations directorate. So currently I am a senior research faculty at Johns Hopkins University. And I was brought in about a year and a couple of months ago in order to help build some of the COVID-19 risk models that have been used currently at this point in time by millions of Americans. But on the academic side, to complete some of the information that I'm talking about today, I am also a faculty over at George Washington University, where I have been working on a couple of different artificial intelligence grants, particularly dealing with AI augmentation, as well as securing the machine learning lifecycle. So the point in telling you guys about my background, as well as pinpointing a lot of the different areas that I worked in, is really to help you understand and to know that interdependent of whether you come from computer science, data science, whether you come from the healthcare field, wherever that might be, there's always an opportunity to apply analytics and algorithms to any of the data within any vertical that you guys might be within. So really excited to be here, and thank you very much.
I'm Juan Lavista. I lead the Microsoft AI for Good Research Lab. This is a complete philanthropic effort that we do at Microsoft. We are trying to fill the gap on using AI for different problems in the world, where a lot of the organizations that have and are working or have the subject matter experts in these problems do not have the capacity to hire AI talent, because majority of the AI talent today goes to work for tech companies or the financial industry. More than 80% of the data scientists and people with the deep learning or computer or machine learning skills are working in this type of the industry. I started my career working for the Inter-American Development Bank in Washington, D.C. I was working there helping doing data science when data science wasn't the word at that point, but doing machine learning and data science, trying to help understand the impact of different projects. The IDB is similar to the World Bank. They were working across Latin America. After that, I went to grad school in Johns Hopkins, and then after that, I decided to go to create a startup. 2008 wasn't likely the best year to create a startup, and that's how I ended up working in Microsoft when the startup failed. And in Microsoft, I started working in running randomized control experiments. So I was part of the group that created the first platform to run massive randomized control experiments. I had part of my background on causality working at the IDB, working with economists, something that I think is one of the big lessons learned in data science, is you need to be able to understand causality. Unfortunately, majority of the data scientists that have computer science background usually lack a lot of knowledge in causality. And that's something that I learned the hard way in many ways. But after learning from economists and then running randomized control experiments, I actually gained a lot of knowledge. After that, that group became Bing.com, that is a search engine. I work in Bing, in Xbox. When Satya and Nadella joined our group, that was a central data science group, started working not just in Bing, but across the company. And a few years ago, I started donating part of our time, me and my group, to help SIDS, that is sudden infant death syndrome, working with Seattle Children's Hospital, trying to better understand. SIDS is when your child dies below the year of 1 and doctors don't know why. So we're working with medical doctors to try to understand that. A bunch of people, including Satya, really liked the idea that we were doing, and Brad Smith, that is our president, decided to start working and create this team that I lead now. And now we work in 4 verticals, that is health, humanitarian action, accessibility, and earth. Talking with Benjamin Khan from Maxar, we're just working with Maxar data. Maxar donated the data for Haiti, so we have machine learning models. We're working with Red Cross, trying to identify the issues with using satellite data that is donated by Maxar. That is great contribution from Maxar, by the way, full disclosure here. And we're working on top of that data to try to understand the earthquake and the impact of the earthquake in Haiti. That helps organizations like the Red Cross. In accessibility, we are working with the Singh AI group. That is an application that runs on your phone, that if you're blind, it can help you navigate the world, from things simple as detecting currency, detecting objects, even detecting colors, and helping someone that has vision disabilities to navigate the world. In health, we work a lot with cancer. We continue working with SIDS. We work a lot. Last year and a half has been a lot of work in COVID, either working with the Department of Health, working with different organizations around the world, with different countries, try to better understand. And again, our team expertise is machine learning and data science, but we partner. So we, as a mandate, we partner with people that have the subject matter expertise. You cannot just do data science if you're not the subject matter expert on the problem that you're trying to solve. That is actually really dangerous. So what we typically do is we partner with people that have that subject matter expertise, and we bring the data science or the AI component to the team. So that's more or less my background. Thank you.
Hi, everyone. I'm so excited to be here with NSCC community and all the great people in the panel as well as the audience. Thank you so much for having me. So I'm a postdoc at the University of Central Florida. I'm working in this multidisciplinary project, Social Sim, that is a DARPA-sponsored project trying to figure out online social media campaigns and, for example, some kind of influence campaigns, or trying to orchestrate some kind of opinion on social media platforms. I'm sure all of you are very familiar with those kinds of campaigns. We see a lot of misinformation and so many weird things over the social media platforms. So that's my current job. My journey started with almost 20 years back in India, when I dropped out after 10th grade and started learning computers from a center back there in 2003. So that was my very first interaction with computers. And after that, I got my plus 2 12th grade, and then got into bachelor's, got undergrad in information technology, and then master's in computer applications, all those from India. Just at the finishing of my master's degree, I was curious about research. I was trying to get into research and do something interesting. So one of my mentors back there suggested me that probably there are 2 people who rule the world, at least in computers. One is who is expert in operating systems, another is in networking. Operating system because everything operates over there, and networking because everything connects with networks, like doesn't matter what technology you're using. So I was very excited about that kind of take. So I got into networks, computer networks. So my PhD, my advisor back there was doing his own PhD in vehicular networks, and he wanted me to do some kind of simulation and analysis of how information is spread, or how information is basically distributed over multiple vehicles who are trying to collaborate. For example, nowadays we are all very familiar with autonomous driving and self-driving and things like that. But like more than 10 years back, it was not that cool technology. People were trying to understand how we can make it work in a practical sense. So I got involved in research from there. We tried some approaches where we can have safety as well as informational or entertainment applications over vehicular networks. So that was not my direct interaction with the data, but since I was dealing with it, and the simulation was creating a lot of data. For example, in 1 second, you have so many sensors in a vehicle which are trying to communicate with in a vicinity of certain area to other vehicles. So that scale of data was very interesting to me. I was like, like how we can leverage or how we can use this data to make autonomous driving a success. But somehow I kind of stuck with the networking side of vehicular networks, not the data side, but I was definitely curious. That was my first curiosity towards data. And after that, I came to US, started my PhD program, again, PhD in computer networks, but that was not in vehicular networks. That was in software-defined networks, trying to optimize the information that we share over internet, and trying to do some kind of scalability issues and things like that, so that upcoming internet could cope up with the kind of technologies that are getting connected to internet. Again, it was not directly to data science, but somehow I took a course in network science during my PhD program here at UCF. So network science is basically about structure of data, how, for example, on social media platforms, there are certain patterns that connect one person to other person. So the beauty of network science is that even if it's not social media platforms, there might be some other, for example, actor network, or let's say cell in biology. There are so many networks which follow the same kind of principles that can be captured with network science. So again, this was like understanding how basically what is the structure of network, what is the structure of data that is interconnected at multiple nodes or at multiple places. So that was my, again, little bit interaction with the data science, but not full scale. That came after the PhD. I'm just coming to there. So after my PhD, I was looking for a research position, and just by coincidence, another research group in my institution, they were looking for someone who has some background in PhD in computer science and some background in discrete event simulation, as well as network science, as I mentioned that I took a course in there. So I applied, and I kind of got my got this position in this this postdoc, and there I started with my like full-time journey to data science. Now, as I said, that we are having this social media platform, trying to capture a lot of data and trying to understand how those campaigns are evolving, what kind of predictions we can make when we collect some data from multiple social media platforms. So, and my expertise there is, as I said, that utilizing that data to find structures over social media campaigns, as well as doing some kind of machine learning and other artificial intelligence tools, for example, agent-based modeling and things like that. So this is my little journey to data science during my postdoc. Thank you so much.
Hi, I'm Marie Desjardins, and I am going to go all the way back to high school when I took a Fortran programming course at a local community college and got hooked on programming. That's how I got into computer science. And then in college, I was more or less a computer science major, but I took an introduction to psychology course as a gen ed elective, and that got me really interested in the cognitive psychology of how human beings learn and understand the world around them. And that's what brought me into an interest in artificial intelligence and machine learning. And this is way before there was such a thing as data science. So I really wanted to understand how people operate and how people think. That was always my driving force. So I went to UC Berkeley for a PhD in computer science. And my dissertation ended up being on autonomous learning in complex environments. So I was studying and developing really novel theories for things like goal-directed learning, experimentation, and autonomous behavior in machine learning. And this is back in the 80s, before people were really thinking about a lot of those sorts of problems. From there, I went to SRI International, which is an industry research lab, and was doing kind of applied AI research there for about 10 years, and then moved back to an academic position as a professor at the University of Maryland, Baltimore County, and spent about 15 years there, continuing my research in machine learning and also multi-agent systems and studying human and system preferences and biases. And that kind of brought me into a real interest I've always been interested in diversity, equity, and inclusion in the field of computing, and the people and who are coming into the field and who are encouraged to come into the field. And I've been thinking more in recent years about diversity, equity, and inclusion in the technology itself. So the biases that we build into data systems and the biases that are inherent in the data that we collect and the way that we use them. I'm now a dean at Simmons University in Boston, so I don't do so much data science, AI, machine learning research myself anymore, but I do work a lot with students who are looking for internships and jobs and careers, and faculty who are doing research in different areas. So I would say my trajectory and my day-to-day work have been a little different than maybe a typical data scientist, but I also think there is no typical data scientist. You hear from us, we're all kind of in this field connected to data science, but there's so many different aspects of data science. And I've applied machine learning and data science models to so many different types of problems. So I was making a list for this panel, and I wrote down oil spill response, building playlists for music apps, distributed decision support, school redistricting, protein folding, tree of life evolution, student modeling and intelligent tutoring systems, like all these different things that we want to model about the world around us use data science. So that's kind of what brought me in. And I think there's a lot of different pathways into the field. So thank you for having me here, and I'm looking forward to the rest of the panel.
Thank you all so much for sharing about your personal journeys and experiences within data science. Next, we'll pose our second panel question. And just a reminder to all of our panelists, please take about roughly 3 minutes for your answers and responses to the questions. And for our last question, you'll have about 2 minutes for your response. So now I'll turn to Benjamin and Juan. And with your diverse and unique career paths in data science, for our second panel question, can you tell us a bit more about how to get a job in data science? Any tips or recommendations you might have for our audience today? Benjamin, we'll start with you.
All right, great question. So first off, in my current position as the Director of Data Science over at Maxar Technology, so when I am looking through resumes to hire different individuals into the data science teams that I currently have, that span from applying machine learning algorithms to overhead imagery to building machine learning algorithms that can be deployed to the satellites. One of the things that I really look for is a portfolio of experience on the resume. So one of the important things for employers that are hiring data science employees, what we're really looking for is someone that can come into the organization that is going to be able to have the necessary background, knowledge, experience, and skill set to really come into the organization, not with a full understanding of every machine learning algorithm or framework that's out there, but has a portfolio of experience where you've tried to apply different machine learning algorithms to different data sets, and there's proof of that, right, inside of a portfolio. So that's one thing that's really important. The second thing is really a broad understanding of different machine learning frameworks. So depending on the organization that you work in a company like Maxar, you will have 10, 12 different teams that are using different machine learning frameworks, different data science packages and libraries across R, Python, Databricks. So the idea is to come into the organization, not necessarily having just one machine learning framework that you know really, really well, but because of the plethora of different types of algorithms that machine learning frameworks that you can use in an organization, having a pretty broad understanding of different machine learning frameworks, as well as deep learning now, across Keras, PyTorch, TensorFlow, scikit-learn, stats models, MXNet, all these different types of ML frameworks. Just get an understanding, explore them so that you can have enough knowledge to be able to put that on the resume as well. And the last thing is really project experience, right? So early stages of SpaceX, Elon Musk interviewed each employee for data science, machine learning, engineering, or engineering positions. interviewed each person, and one of the questions that he asked each individual was, what is the most challenging problem that you've ever worked on, right? So one of the things that I'm really looking for in data science candidates is really, can you talk about a problem that you worked on, the strategy or the methodology that you used to solve that problem, and how did you integrate those results so that they could provide value, right? So one of the things that I think is extremely important is for you to have a story that you can tell to the interviewee, for the person that's doing the interview, so you can really explicitly explain the problem that you worked on, why it was challenging, the solution that you were able to provide for that problem, and really to be able to explain that and to have an intimate knowledge of that is what I am looking for, and a lot of organizations are looking for as well. Thank you.
You're on mute, Juan.
I think you're
I'm on mute, sorry. On my side, so a few things that I think are important is, like Marie mentioned at the beginning, like data science is not one thing, correct? So if we see data science is there's a huge amount of different careers that created that almost everything works with data today, correct? So whether you're a physicist, a mathematician, you work in as an economist, you work as a computer science. So the first thing that I think is important is you don't need to be a statistician or you don't need to be a computer scientist to be a data science. So in my team, for example, one of the most important things when we hire is we're not only targeting diversity of the person, we're also looking for diversity of skills. So in my team, for example, right now, we have economists, we have computer scientists, we have physicists, we have people that have background in operation research. So data science is not one thing. Data science is the collection of all the knowledge that was created. There's no way that someone can have all the knowledge. So that's another thing that is really important when people look at data science. Like, I need to learn so much skills. Like that's not the case. It's like you need to be able to solve problems with data. That's what, at the end of the day, that's what matters. And in order to get a job, you need to be able to show that you can have the skills to solve problems with data. And there are things, usually what I care much is about a foundation, correct? And the foundation for me is you need like, there's a joke that says that data scientists spend 80% of the time wrangling with data and 20% of the time complaining about wrangling with data. And it's true. It's like a lot of the work we do these days is wrangling with data. So you need to have the skills to wrangle with data, correct? That's the first skill. And that requires coding skills. Whether you're programming R, whether you're programming Python, whether you're programming C, it doesn't matter as long as you know how to work with data. A foundational part of that, basically, for example, there are languages that were created, like SQL, for example, that are a very good language to wrangle with data. And that's likely the only language that I learned over 25 years ago that I can still use these days, basically. So long story short, you need to be able to work with data and you need to have the skills to work with data. The second aspect of data science is there's a reason why you have the science in data science, is you need to be able to understand basic things as statistics. You need to understand the difference between correlation and causation. You need to have the skills. And most important, you need to have the curiosity to be able to, given a problem, how to convert, first, even ask the question, why do we have a problem? And you need to, so curiosity is something that it matters a lot in my field. But I think is important, like again, if I need to give one recommendation is do not worry too much about like, about the ability of all the things that are out there. Most important, be able to learn new skills. Like I have people that today in my team that are experts today in deep learning, but they join the team out of the graduate schools. Like they didn't have those skills, but I hired those people because they were really good at learning new skills. And learning new skills is something that will give you you will continue learning forever in this career. So anyway, that's my story. Thank you.
Thank you both so much for sharing your answers and responses to that question. And now for a third panel question, Kuldip and Marie, with your experiences in data science education, how do you prepare yourself to be a successful student in data science? Reminder to all of our panelists again that we'll have about 3 minutes for each person's response for this question. Kuldip, we'll start with you.
Sure. Thank you so much, Scott. That's such a great question. So yeah, there are a couple of things, like from technical side, I'll come to non-technical just in a moment. But for the technical side, there are a couple of things that I faced a lot, and unfortunately, I at the moment don't know how it's going to be solved. Is that no data is perfect. If someone tells you that data is perfect, no, that is not true. So almost all of the data that you use for train your models or whatever purpose is going to be flawed in one or the other way. There might be flaw in the data collection, or there might be flaw in the person who has some kind of biases or things like that. So first, you need to make sure that the data that you're going to use for your models makes sense to you, and you have kind of revised it. The challenge with that is that if your data is flawed for whatever reason, and so the practice in data science usually is to use more data. So if your small data set is flawed, then with additional data, you are basically amplifying the problem with data, and that is going to be reflected in your model as well. So this flaw really makes bigger challenges as you go from small scale data to large scale data. So first, make sure that your data is actually doing what you expect it to do. And the second part is that's again, I kind of face so many times, is that sometimes people try to look at data and try to fit their own narrative into the outcome of data. So I guess that is not a very effective approach to get sensible results, rational results. What you are supposed to do is to formulate your model based on some conceptual understanding. For example, if you're following machine learning, if you're following agent-based modeling or any other technique, first of all, you need to make sure that what are the concepts of those techniques or technologies. And based on that conceptual understanding, you need to connect the outcome of your model with the conceptual expected outcome. You are not going to do it other way around. That means you're not going to get a output and try to fit your own narrative to that output. You're supposed to connect the conceptual output to what your model is doing, so that you know that it is rational and there is no kind of bias or anything like that. So you're not supposed to kind of fit your own narrative, as I said before. So these are the two major challenges that you need to make sure that you're doing correctly. And on non-technical side, the most important thing that I personally feel is that trying to connect with awesome people, just like right now we are doing here, is trying to connect with as many people as possible in the field, so that you get to know latest technologies, trying to get a lot of opportunities and what cool things other people are doing. So try to socialize as much as possible, and you will learn a lot of things. Yeah, that's my advice for all of the audience. Thank you so much.
Thank you. So I think clearly it depends on where you're coming from, right? If you're in middle school now or you're in high school now, what you need to do might be different from if you're working in some other field now and you're looking to change careers. So, take all of this advice is probably coming from one of those perspectives and one of those mindsets. So you definitely need to think about, like, where are you coming from in order for you to be prepared to be a successful student. That said, depending on where you are, strong mathematics, statistics, modeling, simulation, programming skills, visualization, analysis, those are all really important tools. Maybe you should develop some skill with those before you go to a PhD program. If you're a high school student thinking about, majoring in data science in college, make sure you take the math courses and the science courses that are available to you. But equally important is having really strong communication and interpersonal skills. And it hasn't come up so much in our panel today, but being able to listen to people who are in other fields than you are, with different backgrounds than you are, understand their problems and their goals, understand their data and what it means to them, not just to you, being able to learn from them, and then being able to communicate back effectively about complicated technical things to people who may not be technically savvy themselves. Those are really important skills. And especially if you want to be an effective data scientist, not just like in a computer science research lab, but in an organization, like working for a business that you're going to be working with other people throughout the organization, those written, oral, visual presentation skills are really vital. And then the other set of things I would say, and honestly, I would say this to any student, but I think particularly in computing and data science, resilience and a growth mindset and a willingness to try things and fail and maybe ask for help when you need it and speak up when you don't understand something, and kind of developing that self-advocacy and that confidence are really important. You know, kind of sitting back and saying, oh, well, I couldn't do that, I guess I'm done. That's the opposite. That's what's called a fixed mindset. And, you know, we know there's a lot of evidence in particular that people who come into fields where they're underrepresented, so in data science, that would include women, people of color, particularly Black and Hispanic people. If you're underrepresented in a field and that field emphasizes a fixed mindset, you're less likely to succeed, because as soon as you run into a challenge or a snag, it reinforces this message that, oh, well, either you're born to be a computer scientist or a statistician or a mathematician, or you're not. And so I think finding mentors and finding an environment that facilitates a growth mindset and helps you to get past obstacles and to succeed even when it seems like it might not be possible is really important. I wanted to just tack on one quick thing, which is I know somebody asked in the Q&A about going to a PhD program. What you need to do if you want to go to a PhD program is make sure that you want to go to a PhD program. And what going to a PhD program means is doing data science research. So if you don't know what it means to do research and you've never been involved in research, try to find a way to take a research class or get involved in a research lab or a research project so that you get some experience with that and you can write a strong personal research statement for your applications and you have a sense of what you're getting into. Because a PhD isn't for everybody and it's not the necessary next step. If what you're looking for is a practical, applied, hands-on career, going to a master's program or even just going out into the industry and getting some experience might be the right thing for you.
Well, Deep and Marie, thank you so much for your responses. I really appreciate them and all of your suggestions that you provided to everyone in the audience today. I did want to take some time to mention that the NSTC Learner Central actually has some really great resources for all of our high schoolers or younger students in the audience who really would like to get a head start on mathematics and statistics and make sure that they have that foundational background before they apply to college to ensure that they're ready for the maths and stats needed to have a successful student career in data science. And so now for our final panel question, and one of the most interesting questions we'll ask today, I wanted to ask all of our panelists how they expect the field of data science will innovate and adapt over the coming years. Just a reminder to all of our panelists that everyone will share their thoughts and have roughly about 2 minutes to share your responses. We'll start with Benjamin, then transition to Juan, Kuldip, and finally Marie. So with that, Benjamin, would you like to kick us off for our final question?
All right. Thank you so much, Scott. Yeah, so this is an excellent question. So to think about the direction of artificial intelligence and machine learning, this is fascinating. Part of the opportunity in the future is really to build fully autonomous machine learning pipelines. And what I mean by that is currently, if you think about the end-to-end machine learning development process, there's always a human in the loop that exists, right? So from the point of creating the machine learning model all the way through deploying the machine learning model into an infrastructure environment, all the way through to integrating the machine learning inside of the end user application, there's a human in the loop at each one of those steps. Now, the positive about having the human in the loop is because a lot of times you can control for things like bias and drift, data drift, model drift, and things like that. But one of the things that's really fascinating about machine learning in the future is really removing the human out of the loop so you can do things like have a machine learning algorithm, do classifications, backpropagate data, automated retraining, and then automated deployment. So you have this fully autonomous machine learning pipeline. Now, some of the things that you have to control for are still drift and bias, but the idea is with the fully autonomous machine learning pipeline, you have built-in statistics that can help you understand how's the model performing. And as the model performance degrades, you do an automatic retrain and automatic deployment. So everything is fully autonomous. Now, the second thing, that's a very, very interesting question. The second thing is really so you can think of how currently we're creating more and more complex deep learning algorithms, right? That you guys have heard about, the algorithms that have, many layers, across, image pre-processing to, the activation layers, all the way through to, being able to, apply different permutations of the data to help with understanding these very complex images. So you have these deep learning pipelines that have been created with these very complex model architectures, okay? Now, as the complexity of the model architectures, as well as the complexity of the data and the amount of data starts to increase, what we're trying to do is we're trying to mimic more intrinsic human behaviors, right? So things like, curiosity. How can you have a machine learning model be curious, right? Where if it's being trained and it doesn't understand something, the algorithm can go out on its own and find new data that it can retrain itself, right? As well as things as like focus. How can you have a model that is looking at a particular image and focuses in on classifying different areas of the image as well, right? So these intrinsic human neurological behaviors, as we increase the data, increase the complexity of the data, as well as increase the complexity of the deep learning pipelines, we're hoping to mimic some of those intrinsic neurological behaviors. Thank you.
So on my side, I do think that in the next, it's starting to happen, but we will see it even more and more, is different careers, even like from a medical doctor to people studying even history, you will see a much bigger role in those careers to have a more data science component. So you will see that not just computer scientists, statisticians, or physicists will continue, or economists will learn data science skills. You will see it much more broadly taught. That's something that I expect to happen, and it's starting to happen, but I hope that it will happen even faster, basically. So we work very closely with medical doctors, for example, at the University of Washington, and there's very small amount of people in that field that has a medical doctor degree and also a computer science degree to understand things like machine learning. But there's a huge need for that, especially because you cannot solve medical problems if you're not understanding medical problems, and you cannot apply machine learning if you don't know machine learning. So right now, these are usually solved by teams like we do, but we expect in the future for even medical doctors to learn those skills. From a tooling perspective, we will continue seeing, like Benjamin was saying, we will continue seeing a continuous investment in tools, which will make it very much easier than it is today to apply machine learning. We have tools like you can apply machine learning today in Excel, for example, correct? So and that's something that we will continue to see an evolution of that. It will become really much more easy to train algorithms. Today, there's a lot of algorithms that you can train with just clicking on the screen. And that will provide, that will make it easy for anybody to use the technology. It is also risky, and that's something that we are seeing today, is that machine learning doesn't solve all the problems. If we have problems with the data, you can actually generate a lot of problems. These models will have biases, will have drift, like Benjamin mentioned. So that's the part that it can actually be dangerous, especially if we are going to solve problems that will have an interaction with, like, will make decisions for humans. And that's something that things like, we will see a much more investment in things like responsible AI. We will see an investment in really understanding the risk of using machine learning in the scenarios. And of course, there is a lot of risk because you are automating decision making. So if you have a bias in the way that you operate, that bias now will be perpetuated through the machine learning algorithms. So it's something that as a society we need to decide that now, because it's going to be easier, it's also going to be much more proliferated, and there is much more risk for some issues in the future. That's my answer. Thank you.
Okay. So thank you so much for those very insightful takes. So my understanding of data science in coming few years is that I guess right now, like there are so many amazing people who are multidisciplinary and doing a lot of amazing things, but still this field is still kind of narrow at the moment. I believe that in coming few years, there might be more like diverse field where people from different backgrounds are going to get involved in the data science process. For example, in my project, we have like multidisciplinary team from statistics to political science to archaeology and psychology, for example. So I guess that is going to be the case if you really want to capture a very broad perspective of what data is doing and why it's doing what it is doing. For example, let's say if I'm dealing with social media data and that data is coming from a specific region. So there might be like psychographic as well as demographic attributes that, okay, I can probably do machine learning and things like that, but the psychographic attributes, I don't have expertise in that, I cannot capture that. So I need to speak with a psychologist for that. So similarly, for example, if there is any kind of a geopolitical issue, then there might be some political scientists or people from that kind of background who are going to give their inputs to data. So my understanding is that it's going to really broaden. The data science itself is kind of a spectrum where it includes so many fields. And I hope that people with many other backgrounds are going to get involved in the process. And the second part is, so far, the focus of mainstream technologies is on data consumption. I guess there is going to be a trend where we are going to focus on the creators of data. For example, we know on social media that people are trying to say that, okay, whether you want to be tracked by certain companies or certain apps or not. So that is like you are the creators and you are going to get control of your data. I guess that is going to be more prominent in coming few years, and all around, like people are going to decide what kind of data they are going to create and what kind of data is going to get into those machine learning models, so that data can be used for important decision making. And definitely this trend of data is going to be much larger scale. For example, we see Internet of Things and so many other sensor-based technologies which are creating like so much data that it's really difficult at the moment to like process everything and make decisions efficiently. This scale is going to go up as we are moving forward with the digitization and so many other technologies. But how this data is going to be processed and who are the creators of data, I guess that is going to be emphasized more as we move forward. Thank you.
I've lost track. I'll jump in. I think that we're going to see a growing emphasis on data privacy and security and ethics of using different kinds of data. And somebody asked about integrity and incompleteness of data sets and different sources of noise. I think that we collectively need a much better way of understanding, analyzing, and talking about the different sources of incompleteness, noise, bias, uncertainty in the data that we're using and the processes that we're using to generate inferences, and then ways to label and talk about those inferences so that we really understand what the data is telling us and how we got there. And there is a tendency, I think, particularly as more and more people enter the field and use tools that they have less and less knowledge about, but anybody can download R and run a very complex algorithm and get a result out of it. If you don't understand the algorithm that you're running to get that result, you can't really interpret it correctly and understand where the boundaries are. So I think that's a challenge for us as we have this kind of democratization of data science, that we also have less understanding about it. That relates to, for me, a little bit the question about, does AI make humans less intelligent? Not really, but when we lean on algorithms to do our work without really understanding them or knowing how they work, they kind of do. So when we invented automatic cash registers, people stopped knowing how to make change. And when we invented digital clocks, kids stopped knowing how to read analog clocks. And when we invented GPS systems, nobody knows how to read a map anymore. So but we don't know how most people don't know how the GPS works either. So when something goes wrong, it's like there's a brittleness that gets introduced because we rely on those algorithms to do work for us, but we don't know what to do when they go wrong or when they're not actually giving us what we think they're giving us because we don't really understand the assumptions that went into the system. So I think that better understanding of algorithms and figuring out how the designers of algorithms can document and carry the assumptions and the limitations into the outputs will make them more usable in practice in broader environments.
Excellent. So that was a very rich discussion. And so, Haley, where did you want to go now? Do we want to put the slides back up and have Scott talk a little bit about his chapters?
Yeah, thank you, panelists, for that great discussion. A lot of super important insights and pieces of information that we all can benefit from. So now I'd like to reintroduce Scott, who just moderated that panel discussion, for him to talk about his NSDC chapter as he pioneered the NSDC chapters as a whole with his Philly chapter. So Scott, whenever you're ready.
Yeah, thank you so much again, Haley. And yeah, just to get started with everyone, introduce you to what the chapters are. Chapters really help extend the mission of the Northeast Student Data Corps into a more localized format where people can create their own little chapter or system of the NSDC at their respective universities, community colleges, or wherever the case may be of where they're attending, and really provide an impact extending with the direction and mission of the NSDC to their local communities and organizations that can really benefit from what the NSDC is doing. So more specifically for the Philadelphia chapter, we really want to work on uniting students from Temple, Penn, and Drexel to focus on collaborating on interdisciplinary data science projects, initiatives, and educational opportunities, really utilizing all of the wonderful resources that are provided by the NSDC, such as Learner Central for both students and educators, and all of the other fantastic resources, these panels included, to really help provide students with not just intercollegial connections and connections with their own local regions, but also a way to kind of give back to their local communities and really extend this idea of promoting and establishing ways for students to get more involved and integrated into all of the aspects of data science. And so just for a quick overview of things that we're looking to do and start and things that we already have in the works, we really want to focus on connecting students together. So we can do that through coffee chat discussions and also resource utilization from the NSDC, really helping students to connect on both learning data science and sharing their experiences, workshops and mentorship, such as the services that the NSDC provides in a more localized setting. So we can kind of help coordinate logistically in our chapter, students that might need mentorship or could benefit from the mentorship that the NSDC provides. Speaker series like the panels you're attending now, potentiality of summer fellowships where we can have students work on different interdisciplinary data science projects, and also really just focusing on this idea of community-centered initiatives and projects to really take the NSDC initiatives and localize them to the Philadelphia community. And so right now, I'll drop a link in the chat, but if you're interested in learning more about what the Philadelphia chapter is up to, I actually created a link tree that makes it pretty easy to kind of see some of the stuff that we're doing. One of the main things that we're doing actually is organizing with the College of Public Health here at Temple University, a data challenge that really helps students in both high school, undergraduate, graduate, or even professionals to work on interdisciplinary dashboard with the theme of global health. So any topic that relates to global health, such as global healthcare, finance and economics, child health development, humanitarian emergencies, health policy management, et cetera, and really getting students and researchers and anyone that's interested alike to get started in what our panelists mentioned today of thinking about those questions. How do I pose these questions? And how do I create something that adds value or can explain a topic that I'm interested in? And now I'll transition it back to Kelly to share more about how you can actually get involved with the NSDC and how you might be able to start a chapter of your own.
Scott, that was awesome. Thank you for sharing those really exciting opportunities your chapter has in store for students really of all backgrounds. So yeah, like Scott said, I'd like to offer you all more details regarding the NSDC chapter mission statement and structure of the NSDC chapters itself. So like Scott said, NSDC chapters are local student-led communities specific to different regions of the Northeastern US and potentially around the world. Each chapter plans to extend the mission of the NSDC as a local version of the NSDC by creating a community of support for chapter members and extending it through local community development initiatives, very similar to all the examples that Scott listed previously. So these initiatives aim to educate underserved and underrepresented learners in data science fundamentals and provide them with mentorship, research, and career opportunities in data science. So our four main objectives are education, community development, project-based collaboration, and internships and career opportunities. So all in all, it's really an opportunity to cultivate a support system for learners and educators. Our focus isn't just on teaching technical skills. We're also working to provide our community with a space to network and grow professionally. So we're in the process of growing our student chapters. So please email us if you know anyone interested in joining our program, or go on to anybigdatahub.org/NSDC where you can find more information and fill out the NSDC chapter's interest form. Lauren, next slide, please. Great. So NSDC volunteering opportunities. Our volunteers are at the core of the NSDC. The Northeast Big Data Hub has a program called Real Volunteers, which is a group of students who donate their time and skills to our programming and content development. And the Real program, also called the Research Experience and Leadership Program, offers volunteer opportunities to facilitate online events, take notes, curate resources, and more while learning about data science and its real-world applications. So real volunteers who sign up to work specifically with the NSDC are helping to develop open source educational resources and provide other support for data science learners and educators at underserved institutions across the United States and beyond. NSDC volunteers help in event facilitation, including facilitating the Data Science Career Panel series, recording video lectures on machine learning, peer mentoring, curating data science use cases, orchestrating live classes, and honestly pioneering new initiatives to help others discover their passion for the field. So you can see some of their work in the volunteer video library and apply online if you're interested in joining our volunteer program and contributing to the NSDC. This really is a great opportunity to learn new skills by teaching others. And you can also participate in our online events, of course, and join our other growing programs. Next slide, please. Great. So with every initiative the NSDC creates and pursues, it's super, super important to underline the human element to it. So on the left, we have a screenshot of our June data science career panel with student volunteers Flavio and Gary from Queensborough Community College facilitating the Q&A session. And on the left, jokes, on the right are the volunteers Tomislav and Yusin, two Columbia University master's students who recorded and instructed video tutorials. So Yusin's was on introductory data science material, while Tomislav's was on supervised machine learning. So these are just two instances of how you can volunteer with the NSDC, but as I mentioned before, there's a variety of volunteering opportunities for you to discover and take part in. Next slide, please. Okay, so as we're winding down, we'd like to thank everyone who's been a part of this panel event. Special thank you to the panelists, of course, for sharing their insights and journeys with us all. And then the outreach team, who are really the ones who built this from the ground up, starting with an idea and making it into a regularly scheduled series of the NSDC. We have our moderator, Scott Blender, for leading the panel discussion and sharing his story and contributions to the NSDC chapters and beyond, as well as our 5 facilitators, Faru, who actually leads the outreach team and has been overseeing the chat, Lauren, who's been screen sharing and live streaming, Brian, a volunteer who's taking brilliant notes for this event's upcoming blog post, and Juan and Benji, who you will all hear from very soon during our post-panel Q&A facilitation. And a big thank you to the Hub's Executive Director, Florence Hudson, who's helped in every aspect of this event and the series as a whole. So thank you each for your hard work, collaboration, contributions to making this event and the series so valuable for so many people. And finally, a special thanks to all of you tuned in today or who'll be watching the recording later. This wouldn't be a success without you all. We really hope this panel was super helpful and rewarding. And please keep the conversation going through our Slack channel and all the other ways you can keep in touch with the Hub, which I'll be talking about in the next slide. So yeah, like I said, let's keep the collaboration going. As I mentioned earlier, you can leverage free online NSDC resources at anybigdatahub.org/NSDC, including math and statistic-based courses in the Learner Central, as Scott discussed earlier. Also, feel free to sign up for the newsletter with that same link. Our next data science career panel will be held on Friday, October 29th. So you can register at the link presented. And we all know how powerful a tool social media is. So definitely follow us on Twitter at data_corps for any updates and information with the NSCC. And we will have a recording of this event actually up soon on our YouTube channel. So we encourage you all to subscribe to our channel for further updates via the bit.ly in the right corner. And finally, you can scan that big QR code in the middle to join the NSCC Slack community. Next slide. Great, thank you, Lauren. So now we will be transitioning into our post-panel Q&A session, where you all, the attendees, have the opportunity to have your questions answered by today's panelists. So we're going to do this a bit differently today. So registrants of today's events had the opportunity to post questions they'd like answered during the panel. So we have our two Hub assistants and Q&A facilitators, Juan and Benji, overseeing unanswered questions and posing them live to the panelists. Juan will pose any unanswered questions from the Q&A chat box, while Benji will pose questions from our registrants pool. So we'll start off with Juan, who'll be posing our first question from the Q&A chat box to the panelists.
Thank you, Haley. We received so many great questions here, and the first one that I want to bring it up is to all of the speakers is, do you think AI makes computer more intelligent, but humans more unintelligent? Yeah, please give us some your take on the question. Thank you.
I can try to answer that question. I like what Marie mentioned before, but on top of that, I do think that the rightly used AI and machine learning can augment our intelligence, and that's something that some people mentioned, that AI is not necessarily artificial intelligence, but augmented intelligence. Really. So I do think that it's a tool that can help us even perform more, like similar to what we saw when we went from like coding assembler or even in the days of coding Fortran to what more modern programming languages allows to do much more, basically. So I do truly believe that things like AI or machine learning can certainly augment our intelligence.
Great, thank you, Juan, for answering that question. So next we'll have facilitator Benji pose a question from the registrants pool to an open discussion with the panelists. Benji, take it away.
Yeah, thank you. So the first question I have for our panelists is, what would be the best approach for someone in the biomedical science field or within the healthcare background, with a healthcare background, who's looking to make a career change into data science or data analytics?
So Benjamin, I think you have quite a bit of experience in that. You've been working on different health things with Johns Hopkins and things like that. I think we touched on this a little bit earlier, but maybe you have some comments about going from biomedical research or biomedical applications or health in general into more of a data science career.
Yeah, no, perfect. So I would say, so there's kind of two different ends of this spectrum, right? So in a traditional data science organization, there's a lot of projects that you will work on where you are specifically responsible for developing models, doing things like data engineering, developing models, and applying or operationalizing those models for and across the organization, right? So really responsible for getting the results of the data science models into the hands of the end users, right? Which requires a lot of interfacing and interaction with the IT organization, and requires a lot of interaction with the data scientists all the way through to the data engineers. So it's this ecosystem that you really, really have to learn to work in. Now, and that's from a data science director kind of perspective at Maxar. Now, on the other end of the spectrum, I've worked within organizations like Johns Hopkins, Harvard Medical School, and I've been a bioinformatician, a data scientist that was responsible for applying machine learning algorithms to large-scale genomics data sets, for an example, but as well as when you think about healthcare professionals and researchers, a lot of times they want these very agile applications that they can use for experimentation, right? So there's this component where you're building these tools and you don't have to go through this entire operationalization process where you have to have 30 layers of testing so that you can make sure that it works extremely robustly, right? So the development cycle is very shortened, right? And for someone that is just getting into the field and just learning how to build algorithms and applications, that's a niche area that I myself was able to flourish within, right? So I was the area of really the application for someone with a background like yours would be really finding opportunities that will allow you to work with healthcare professionals that want to build applications that they can rapidly prototype and get out into the hands of end users. And you can use your skill set of the bioinformatics, think about the MPH that you might current or pursuing and you might have to be able to specifically apply your skill set to rapidly develop and prototype for that organization or for those healthcare professionals or research professionals. And I think that'll allow you to really expand your skill set without having to worry about going specifically into an organization where you have to work across the IT organization and build these products where you have to do a lot of software engineering. That niche area is within working in research organizations and applying those machine learning data analysis skill sets.
Very interesting. Are you able to hear me? My internet is blipping a little bit. You can? Okay. So actually, we've just posted a couple of postdoc opportunities at Columbia in health and data science. Interesting you bring that up, Benjamin. You made me think about that. And I think we have them in Career Central on the NSDC. So Lauren, maybe if you could do us a favor and plop that into the chat so that people can find Career Central, and you could look in there for that. And I would like to say, if there are any other educators or people who hire people who would like us to put any specific opportunities into Career Central, we're happy to do that. And so there are a couple in there right now at Columbia, and I'm sure there are many more. And I guess, Benjamin, if we were trying to give them some advice on where they would look for those opportunities, would it be like an academic medical center, like a university that has a hospital, or maybe a data science institute? I think it could be either of those, perhaps. What do you think?
Yeah, definitely. So there are a lot of opportunities across, when you think of universities that have hospitals, right? So any university that has a hospital, universities that have specific biostatistics departments where there are research professionals that work in those departments that have resources and grants that are pursuing building data science applications. So it's a couple of things. A lot of those opportunities will be openly available when you go out to these different healthcare organizations within these institutions, but also there's specific opportunities for researchers in the healthcare fields that have grants that are looking to build applications. And it's more of identifying those opportunities by reaching out to some of those professionals. Sometimes when you have to specifically figure out where they are, but a lot of times they're listed, but sometimes the grants that individuals have, they're not always immediately posted, but a lot of the PIs of those grants are always looking for help from postdoc undergraduate researchers or graduate researchers. And those are the sweet spots that I think that, a person like yourself could really get into.
Very cool. Yeah, let me add a couple other things. I bet you Juan would have some ideas on this too, as well as what you can do is go to NIH, the National Institutes of Health. They have a reporter tool, REPORTER, NIH reporter, and you can look at all the NIH awards that have been granted, and you can put in topical areas you're interested in. And so that's one opportunity. Another is that NIH has a brand new solicitation that came out that I think is due today, which is the Bridge to AI Center. And so there's going to be a lot more opportunity when those are granted. I think it's going to be in the next couple of months. They're trying to get this stuff out there so that they can get AI and data and all sorts of things going on more deeply and broadly across NIH and the healthcare space in general. So look for that type of stuff, NIH Bridge to AI. There was another one called Aim Ahead. So if you go to NIH, you can learn about that. We also have some of this on our COVID Information Commons site, which Lauren can put the link to in the chat. And if you're interested, our real program for volunteers is called Research Experience and Leadership Opportunities. And so you could go to our volunteer website and say that you would like to, do some research, have some research experience in these areas. And we have a lot of collaborators throughout the hub. We have like 4,500 individuals we've touched since we were born in 2015 as the Northeast Big Data Hub. We have 1,500 people in our COVID Info Commons community, and we're always creating collaborative opportunities. So, reach out and join our real program, and then tell us what you're interested in, and we can get you connected. Okay, Haley, what's the next? Who's doing the next question?
Great. Well, thank you, Benjamin and Florence, for sharing the steps as well as opportunities for people with biomedical backgrounds. So the next question will be posed by Juan, who will be extrapolating a question from the Q&A chat. So Juan, take it away.
Thank you. So with the ever-increasing interest in data science, do you think the middle school students are ready to receive the integrated instruction driven by data science? For example, combining coding, math, modeling, or visualization.
So I guess I have some opinions about this. I think that evidence-based reasoning and data-driven understanding should be more infused across the entire curriculum than they are. So I don't think that we need to have like data science courses or, data science, whatever. Necessarily, maybe like a unit here or there. I think we should have more computing all the way through school. I think we should have more statistics all the way through school in the math and science curriculum. But I also think history classes should be using data science to visualize history and to understand the things that students are learning about. We can look at population shifts or how languages have moved around the world. We can look at evolution, and we can look at English literature and the words of Shakespeare, and what are the ways that our language shifted when the printing press was invented. Like there's so many different things that you could think of where you could integrate data analysis and visualization into the things we want our students to learn. And that's what data science is. It's a tool for understanding. So I would say, yeah, of course, students should be learning about data science, but we should be sneaking it in. They should be learning it because they are using data science. And then we can help them to understand how they could use data science themselves to understand completely new things.
I think that's wonderful. And, Marie, I love how you were so ready for this question, that middle school students, right? Because, we're Columbia and we're hosting this and we have all these, fancy people from Microsoft and Maxar and all these cool places. And to actually say, yeah, and you can get started early is so true, and we're very passionate about that. And actually, Lauren, our operations communications manager, God bless her for being so patient with me, can put in another link in the chat. One of the other things we have is a data science resource repository where we've been curating things across a wide spectrum. And one of the things we have is actually a couple of activity books called Big Data for Little Kids. And so it's actually for 4 to 8-year-olds. You can even start earlier if you want. And it was created by the New York Hall of Science, which is the Old World's Fair for people who are old enough to have heard of that. And they actually have a very hands-on museum kind of, but it's the Hall of Science. And they actually have a lot of activities you can do. And they talk about how to help children and humans think about data. Think about the information, think about what they're learning. And so you can start at a very young age and get them going. And then there are also materials in there if you're going to teach data science at high school or whatever. So there are educator materials and learner materials. And then, stay involved, stay connected to us at the Northeast Big Data Hub. We have a lot of these activities going on, a lot of programs. And then we have to be careful for volunteers under the age of 18, we've been learning, but stay, you can always connect and listen in on all of our stuff to get you started.
Great. So thank you, Marie, for answering that question, and Florence, of course, for you following up and offering more really important information for everyone tuning in. So the next question will be from Benji, who will be taking this question from the registrants pool.
Yeah, thank you. So this is a question similar to the first one that I read out. So this question says, how can someone with a computer science degree see themselves pursuing a career in data science or data analytics?
So I think a couple of you have computer science degrees, right? Who wants to speak up?
Yeah, so I can answer that question. So anybody like computers, if you have a computer science degree, you certainly have a very good background in coding and programming, which is really important for data science. It's not enough, correct? So you will need to learn statistics. You will need to learn the science part of data science, basically. Like you will likely have enough knowledge of working with data, or at least programming to work with data, but certainly you will need to work a little more on the science part. And there's a bunch of courses, either online. A lot of times is you would need to do by learning by doing. And I like the idea of volunteering. There are organizations that organize either hackathons or actual, you can volunteer specific projects like DataKind, for example, can do that. But certainly there's a huge amount of very good, amazing courses of data science that are online and are free from the best professors in the world. Right now, you can get access to majority of those courses.
Absolutely. And a lot of them, they're a lot in Learner Central. We have, UC Berkeley's Data 8. We have the MIT Missing Semester. We also have, I'm just getting started. Like, how do I even think about this? We have links to some of the Khan Academy classes on pre-algebra and algebra and math and statistics. So you can go to Learner Central on the NSDC and get access to a lot of this material. It's free, online, openly available to all your friends around the planet and the International Space Station as required. So please feel free to share it broadly and use it. So that's great advice. Thank you. Back to you, Haley.
Great. So Juan will be posing the next question, and this will be from the live Q&A.
Thank you. So what do you think about or how dangerous it is in terms of the people who are utilizing AI and machine learning to create a deepfake or to pretending the real people in the current life? Yeah.
I mean, I think this is part of a much broader set of problems of our increasing reliance on our information ecosystem and the increasing fragility of our information ecosystem. Mm-hmm. So there's all this information that comes at us every day, so we think we know more, but if that information isn't accurate or isn't complete, we actually know less than we would if we didn't have that ecosystem. So we know a lot about disinformation and misinformation in social media, but these kinds of data science, deep fakes, and ways of biasing and reselecting and putting out data that's not accurate or that's been tampered with or that's been kind of curated to mislead people is really, really problematic. And honestly, I don't think we have any good solutions. I think the person who asked this, or one of the people asked this type of question in the chat, said something like, well, should we make all data sets sort of be publicly available and curated? And, maybe yes, but does that actually help solve the problem? Because how do you make sure that like who certifies data sets? Right? I mean, it just sort of begs the question of how do we know that the data, the information that we're seeing is accurate? I think it's a really big problem. I don't think we have very good solutions, but I think some solutions are out there about kind of chain of ownership of data sets and of videos. And I think also the other thing is to educate the public more about understanding the sources of information and data that are coming to them, and maybe starting to think about holding people accountable for spreading information that is knowingly incorrect. When would that be an appropriate thing to do? These are tricky policy questions, and by the way, they're international questions because the laws around spreading information and around security and privacy and all of those things vary greatly in different countries. So these problems are different, but information crosses international boundaries.
Yeah, and and I'll spend a second to piggyback off of that. But a lot of organizations now, and we have this at Maxar, a lot of organizations are hiring artificial intelligence assurance engineers. So these are engineers that are responsible for securing that machine learning lifecycle, right? So whether there's a human in the loop or whether the machine learning algorithm is making a decision, they're responsible for integrating security checks and measures to ensure that, when you think about adversarial machine learning, specifically in areas where you have things like patch attacks, where patch attacks where you can change pixels within the image, and the machine learning algorithm starts to give you inaccurate results, or membership inference, or model inversion, and all these different types of attacks that an adversary having access to the models within an organization could actually perform. So because of some of the intricacies and vulnerabilities associated with the machine learning lifecycle, a lot of organizations, in order to provide a solution for that problem, are hiring specifically data scientists that have this flavor of skill set that can help an organization understand what are the vulnerabilities inside of that machine learning algorithm, inside of that machine learning pipeline, so that they can apply different measures, security measures, to help address those.
Thank you so much, Benjamin and Marie, for those really elaborate and important answers to that question. So I think we have time for 2 more questions. So we're going to receive one from Benji that comes from the registrants pool, and then another one from Juan from the Q&A. So Benji, feel free to pose a question.
Yeah. So this is some sort of a follow-up to the previous question. So in your answers, you mentioned that people trying to pursue data analytics online courses and data science courses online. So in terms of like getting a job in the data science field, how are these data analytics certificates, like from online courses, like perceived in the recruiting process?
Yeah, and I think part of that was the certificates versus a degree, right? Do the certificates really help or not? So I think some of the attendees are trying to figure out, what path should we take? Should I get a certificate in 3 months, or do I have to go get the degree, or can I get started and then do an internship? That's part of what I was thinking before too when I was listening is, so how do you get all this experience? If you want to get started, are there internships you could get, or a certificate help? Are there any recommendations any of you would make on that?
Certainly, the most important thing is the skills and the knowledge. Basically, how do you get that knowledge? It can be from different things, different areas. Of course, degrees help as a way to get into jobs. Sometimes it's like it's going to help you, but you still need the skills, and you can get the skills without degrees. So I think it's a little bit of everything. I do think in the future, not now, unfortunately, but I think in the future, people will pay much more attention to skills and to like the things that person can do, and necessarily to degrees. Right now, the degrees are still required for many of the opportunities, even to get into the door of a job. Sometimes that's the requirement. So,
Yeah. I think that's really good advice. And, one of the visions we have for the Northeast Student Data Corps, as Haley said, is to reach out to communities that don't have access to data science education. They don't even know what it is. They don't know that it's a thing, and it's a big thing, and it's going to be everywhere. It's going to be like oxygen, as long as we still have oxygen with climate change, but it's going to be everywhere. So one of the things that we can do is to think about how together, with all these great people on the phone here and the others in the community, create opportunities for experience, create research experiences, create use case explanations, teach explainable AI. I don't know exactly what we can do, but this is something that we've been thinking about so that we can help them find internships or get research experiences through the hub. So for people who want to help us with that, we would love to talk more about it, because then we can help create that environment for you that Benjamin is talking about and Juan is talking about, and Kuldip and Marie, so we can get you started anyway. I know that some of the students on our hub team, like Benji, they get to do projects with us, and then that actually helps them get internships and jobs when they talk about what they did. And so we really want to help with that. So, anyone who wants to participate in that, either way, if you're a student and you want to participate in that, fill in the volunteer form, we'll hook you up. And also professionals and educators can be volunteers as well. So we're really building this community to grow and help all the humans.
Right. Ditto that. And then so we will end our Q&A panel with the last question from the Q&A chat box that Juan will pose to the panelists.
And unfortunately, we need to leave because I have another meeting, but thanks everyone.
Juan, this was great. Thank you for your time. We'll be in touch.
Thank you very much.
So the last question for today's panel is how can an adult, especially from the underprivileged communities, get a foot in the door without having to get into the student debt in the state?
Good question. Any thoughts on that? How do you stay out of student debt and get started?
So first of all, there's just so many free resources online right now to learn more. The challenge is that that lets you learn a lot. It doesn't necessarily help you get your foot in the door for a position, because, nobody knows that you took those classes, or, maybe you did, and nobody can really measure what you've gotten out of that. There are a lot of organizations, and obviously this organization is one of them, that can help you make some connections depending on where you are and what you're doing, whether you're a student or working. The answer is going to be different. There are a lot of scholarships and a lot of opportunities for students to pursue, depending on what community you come from, what state you come from, what your background is. So, finding some connections that can help you understand for your particular situation. I know edX and Coursera and Udacity, and there's all these organizations that have these free resources to help you learn, but you may still need either some experience or some kind of recognized degree or certification in order for people to take a chance on hiring you for a position. So it's sort of like bootstrapping that. So you take a few free things, and that maybe lets you get into a project with a professor if you're at an institution, or take on an internship opportunity, or do a side project where you could build a website that shows some of your skills. And then if you apply for a position, you have a thing to point to that you created, that you accomplished, that you can say, I know some stuff and here's the demonstration that I really know it. The other thing I would say is if you are going out and applying for positions based on maybe a less traditional suite of experiences, that you need to work really hard on your cover letter. You need to make sure that you have a really clean resume, that it looks great, that your letter is tailored and says why you're applying for the position you're applying for and what skills you bring to the table. I see a lot of people who apply with like a generic letter that isn't responsive to the particular position, doesn't highlight their skills. Find some organization that you can connect with that can help you tailor your resume and have a really good application, because that's just going to make all the difference in the world for a lot of folks.
So on that note, Haley is going to be mentioning the poll that we're going to have. We're going to be sending out a survey, I think, after this event. And we're asking what other types of events you would like. And we're thinking of having like a resume workshop, an online resume workshop. So Marie, great lead in as with everything else you said today. And so you can respond to that. And, we're thinking of how best to do that. I know Juan has actually mentioned there are some Columbia resources maybe able to leverage. I do a lot of mentoring and stuff like that, so we can help, and maybe some of our other folks and panelists. So we would be happy to help you with that. And, between us, we may be even able to figure out an REU, a research experience for undergraduate type program that we could tack on to what we're doing at the hub to actually support this. That's what you all are making me think. And we can, build that as a community. So let us know what you want, what areas interest you. Submit the volunteer survey. You can use that as your vehicle. Send us an email at nsdc@anybigdatahub.org, which is on the bottom of the NSDC website. We're all about our community. We love to listen. As Marie was saying, a data scientist listens first because you need to understand what the problem is. And then you try to come up with various alternatives and solutions. So please keep communicating with us. We're delighted that you're so engaged. We're delighted that you're starting at the middle school level and going all the way to adult learners. And regarding the adult learner that just was asking about retooling themselves, there was a gentleman who's a serial entrepreneur who joined our workshop, our webinar a couple of months ago, and reached out, and he was looking to retool himself with COVID, and what is he going to next? And he was interested in data science, so he's getting his MBA from Southern University, which is the only HBCU system that we have in the country. And so we had a great conversation, and we got him all motivated. And he pinged me on Slack a few weeks ago and said he got an internship. And so we can help you. So, reach out to us on the Slack channel. We're actually looking for more people to help mentor industry people, academic, anything, because there's so many questions people have, nonprofit, government. So join the Slack channel, offer to help people. You can go into the mentoring sub channel in there, and we'll work on giving you a hand. And it's really been such a pleasure. It's so inspiring to have these discussions. So thank you, all the panelists and the facilitators and moderators and students and everyone who's participated, and especially Haley, who's we're all following you, Haley, into the future.
Well, thank you, Florence, and thanks for those kind remarks. And yeah, I think that ends our panel. Thank you everyone for tuning in. Thank you panelists and everyone who helped, as Florence said. You will have to, or please fill out a poll survey following this event. Tell us what you liked from this. Tell us what you want to see more of pertaining to, future community events, including like what Florence said and what Marie kind of touched on, resume workshops and all that stuff. So thank you all so much. And yeah, stay connected.
Thank you. Thank you for having us.
Thank you. It's been great. Be well, everyone. Stay safe, and we'll see you again.
Bye, everyone.
Thank you so much.